This is Algebra 2, Unit 4, Lesson 12, the rest of the notes on the natural logarithm. Okay, so when we talk about the natural logarithm, remember we said it's a special form of a logarithm. So we did part A and part B from the Ed puzzle. So we said for this particular problem, t of 0 was 168, and t of 60 means after 60 minutes. The temperature is 83.7. That's where we left off. All right, now how do we calculate using the natural logarithm? Well, let's take a look. Using the natural logarithm, determine algebraically when the temperature of the liquid will reach 100 degrees Fahrenheit. So if we take our equation here, 101 e to the negative 0.03 m, and then plus 67, we want that to equal 100. All right, now this works exactly like the logarithm function because natural log is a logarithm. So we have to get the exponent by itself. So first thing we're going to do is we're going to subtract the 67. And we get 101 e to the negative 0.03 m equals 33. All right, now we want to solve this for e, so I'm going to divide by 101. So if I do 33 divided by 101, here's my calculator, 33 divided by 101, and I get a freaky decimal, math, enter, enter, just leave it as a fraction then, is 33 over 101. Okay, so we'll just leave it as that. All right, so we have e to the negative 0.03 m equals 33 over 101. Okay, now, in order to get an exponent, we have to do a log. But since this is e, we're actually going to do the natural log. So instead of doing log of both sides, we're going to do ln of both sides. So I'm going to take the ln of both sides when we do this. Okay, so since this is a log, what do we do with the exponent? Well, the exponent goes out front. So this becomes negative 0.03 m ln of e is equal to ln of 33 over 101. Okay, now what is ln of e? Remember, e is the base. So e to what power is e? That's just going to equal 1. So this is actually going to cancel out. So I'm left with negative 0.03 m is equal to ln of 33 over 101. So to solve for m, we just divide by negative 0.03, and then we should be done. All right, so this is what I'm going to put in my calculator. All right, let me clear this out. I'm going to do it as a fraction. So it's ln, or excuse me, let me do the fraction first. So ln is right here next to the 4 key. It's right below the log key. ln of 33 over 101. And then divided by negative 0.03. And you get 37.287, and it's said to the nearest tenth. So m is going to be approximately 37.3 minutes. Okay, now you can also do this on Desmos using the keyboard down here. If you want to do ln, if you go over to the function key, right where the log is, and under miscellaneous, log, ln is right above it. So if you need to do ln there, you can do it there. So it would be ln of 33 divided by 100, forward arrow, parenthesis, there we go, divided by negative 0.03. And you can see, oops, did I get the right one? Yeah. Oh, 101 that's supposed to be. There's where I goofed my answer up here there. Okay, so it should be 33 divided by 101. Sorry about that. All right, so you can see we've got the same answer here, 37.28. It helps you put the right numbers in. Okay, so you can see you work a natural logarithm just like you do a normal logarithm. The only difference is you use ln instead of using log. All right, so for the last one, on average, how many degrees are lost per minute over the interval from 10 to 30, round to the nearest tenth of a degree? All right, so if we want to know what loss per minute, isn't that the average rate of change? Yeah, all right, so let's take a look. T of 10, let me put this in my calculator. Y equals, let me see, 101. E is the inverse of ln, so you can see right here in blue, second ln, e to the negative 0.03 m, and I'm going to use x, and plus 67. Make sure you get off the exponent when you do this. All right, so if I go to 10, all right, let me see, table set. I'm going to go to start to 10 and look at my table. I can see it's 141.82. All right, so that's going to be 141.82. And then the other one is T of 30 is going to be the same value. We just put it in here. I'm going to go to 30. I'm going to jump to my table start at 30 so I can see this immediately. And it's 108.06. Okay, so your change in your temperature is, if I subtract these, I end up with 141.82, 141.82 minus, what was the rest of it? 108.06. Enter is 33.76. Okay, so that's the change. All right, so that's 33.76 degrees over per minute. How many minutes has this been? Well, from 10 to 30 minutes, this has been 20 minutes. So change per minute, if I divide this out, 33.76 divided by 20 is 1.688. So this is going to be approximately, to the nearest tenth, is going to be approximately 1.7 degrees per minute. Okay, so that's the rest of the notes for natural log and logarithm, so you can work out the assignment that goes with this.